I think that there's a couple aspects to determine whether you're going to be interested in chemistry. There's some practical considerations, and that is that chemistry is a good preparation for a variety of positions. It's a great preparation for medical school. It's a great preparation, well, I would argue it's a great preparation for anything. I think that chemistry, the focus in chemistry is often understanding, it's not memorization. And we do a lot of writing, which is very important. You find most fields having good technical writing skills is very important, and that's something we focus on in chemistry. And so I think that chemistry is just generally a very good undergraduate degree to have, because I think it prepares you, it really builds up all sorts of skills that you can use in a variety of fields. I think also for me it's very interesting. So that might not be true for everybody, but for me I really like looking at the world from a chemical perspective. I like, whether it's biology or more physical processes, I like thinking about how molecules are really bumping into each other and interacting, or in biology, what's the hydrogen bonding signature that's taking place, so a much more fundamental level than potentially, or I would argue potentially, than just a series of upregulations, downregulations, and things like that. So, yeah. So those are the two things that I think. I think it's interesting, but it's also practically, I think it's great, a great education. So the best book that I would think that would prepare somebody to see if they have an interest in science might be Bill Bryson's book, A Short History of Just About Everything, I think it's called. And he's a very funny writer, and he really does, he gives you a whole history of, it's more earth science, biology, and chemistry, but it really presents science in a very easy way. And if you're interested in the environment, then you could also read Rachel Carlson's A Silent Spring, which was one of the first environmental books that talked about how DDT contamination was contributing to the thinning of eggshells, especially in peregrine falcons. And so that's why it's called Silent Spring, because there's no more birds. So that's also a very interesting scientific environmental book. You have to, I don't know, don't be too hard on yourself, I think is one thing. It's hard. So the beginning of school is hard. So all of your classes, and this is especially true in chemistry, and I think it's true across the disciplines in science, is that the initial courses tend to be very difficult because it's similar to learning a language. You're learning the language of chemistry. You're learning how we speak in chemistry, how we speak in biology. And sometimes that's the hardest thing to learn, is the very, very beginning. So it's okay. You may actually do better as you go on in upper years because the courses become more focused and you have this fundamental background that you're building upon. So I think that's something to keep in mind, is not feel that, well, I'm struggling, I'm never going to be able to do anything else. That may not be true because sometimes the beginning is the hardest. So I think you should investigate and avail yourself of all of those opportunities. So there's course-based opportunities, like the 99 courses, so like 199, 299, 399 is a bit different, I think, and 499. Those are definitely, if you intend to go to graduate school, I would definitely recommend doing the 499 project. Besides the classes, there are also, it's sometimes not a bad idea to look into volunteer opportunities because you can do very interesting things that way, and professors may have projects that they could take you on, but they don't have money to pay you. There are also summer research opportunities that you can apply for. So in chemistry we have the USRA, which is the undergraduate research summer apprenticeship or something, so you can apply for that in chemistry. So I think one of the things that has to happen eventually is that you have to start reading scientific literature. So whether that's fostered in a specific course that you take, or whether if you go into graduate school that's really going to be the main source of information, is not going to be textbooks, but it's going to be primary scientific literature. So it's not a bad idea to try to learn how, it is a very good idea to learn how to search the databases, use the search engines, find interesting papers, especially if you're doing research, then those sort of tie together. You can find scientific papers yourself on the research topics that you are investigating. It could happen that if you do graduate school that you are going to want to read some papers, but in an area that you are outside of. So it's a good idea to get started trying to read them even if you're not in that area, because it's very difficult at first, but you'll get used to it. And you'll that's how real scientists obtain information, is reading scientific papers. Yeah. For both applying for graduate school and getting a reference letter, that research experience is the most important thing for both of those things. They want to know whether you're going to be productive in the lab. Your grades can be a good indication of that, but they're definitely not everything. It's not uncommon for students to make it into grad school with a GPA below the cutoff, but very good reference letters. So you want a reference letter that can speak to your abilities to work in the lab, and the only way to do that is to do some research. So you want somebody to be able to give you a reference letter that says they work independently, or they are good at working with their hands, because chemistry is actually, most science, you actually have to do something. You're not just learning and taking tests, you have to do something. So you want somebody to be able to write you a letter that says they can do things with their hands. They can make things work, and they can work efficiently, and they can work independently. So I think in both cases, reference letters are very important in graduate school, and having reference letters that can actually speak to what people want to hear about is very important. Yeah. You really need to sit down. That's how people are productive in graduate school, is they keep focused on that goal. And because sometimes in graduate school and in research in general, research will sometimes take strange twists. And you have to recognize when something's not going in the right direction and maybe you need to change it, or if it's going in a really good direction and you want to keep going that way. So you need to stay focused and always think, is this going in the right direction? Am I doing the right thing today? Don't try to act as an island unto themselves and do everything on their own and reinvent the wheel every time. If they're going to try something, they look in the literature first, and they become well versed in what they're going to do, and then they also talk to other people. They email professors at other universities and say, I'm trying this new technique. Is there any advice you'd have for me? Or can I come visit your lab? Because we haven't done this before. So it's really, people who are very successful in research are people who avail themselves of those types of things, which is sometimes difficult for students who've been very successful in undergrad. So that's why there's not necessarily a perfect correlation between your grades in undergrad and your success in graduate school. The other thing that most people, I think, will find in graduate school is it involves a lot of failure. So it involves a lot of trying something and it doesn't work. And then you're like, oh, and you try it again, it still doesn't work. And you just feel like it's beating you down over and over again. That's okay, because the people who are really successful in life are people who fail and keep going and try again and find a solution. And that's one thing we don't foster in undergrad. So your grades don't reflect your ability to overcome adversity. I think you have to keep in mind that this is very discipline specific. So some disciplines, publishing 2 papers in your PhD is a lot. And maybe they will go into higher impact journals. In my field, it just happened that it's not uncommon to be able to get out more than 1 paper a year. Partly because some of the things we're doing just yield results. So if we look for a chemical that's never been looked for in the environment before and we see it, there's a paper. So it doesn't require as much. It requires work to make sure we can see it and find the samples and everything, but it's not the same level of work as some sort of, if you're growing cells and you're doing all sorts of things. So you have to keep that in mind. I mean, some people publish mostly after they're finished, but to have a successful PhD, you have to have scientific papers come out of it. So if you're doing something and you say to yourself, you have to say to yourself, can this be published? Will this be publishable? That's very important. That is almost the most important thing. That is what will make you successful.
眼看